Hello world, it's Siraj, and I've built an automated trading bot. In this video, I'm going to show you how I built it. What you're seeing behind me is my automated trading bot. It's running locally on my machine, but it's a user interface that I could easily upload to Google Cloud, AWS, whatever cloud service provider I want for both personal use, or I could turn it into a service and sell it. So what you're seeing here is the result of what's called backtesting. And backtesting is a strategy in financial automation that involves taking an algorithm and applying it to historical data to see how well it does. And the result for this backtesting span was about 12% in profit. So I had a starting price, an ending price, I had a time span of 3 months to test this on, and it made about 12% in profit. So what you're seeing here is the chart of Bitcoin prices over the last 3 months. And all the green dots are where my algorithm decided to buy, and all the red dots are where it decided to sell. And ideally what we want are the green dots to be lower than the red dots, right? Buy low, sell high. And that was the case. I made 12% profit in this back test, and here are all my round trips, my profit and loss, the percentage, etc. But this is a really cool user interface. It's called GradientTrader. That's what I've called it. And what you can do is you can pull data from many different exchanges. So you can say, well, the Poloniex exchange is the one that I chose to pull data from, Bitcoin data, but we can pull it from a bunch of different, as you see here, exchanges, and then use that data to train our algorithm with. So I went ahead and imported the Poloniex data, and then under backtest, I said, okay, let's see what data I have. It found it because I already downloaded it. I can click on it and say, okay, this is the data that I want to train my model on. I want to perform backtesting on. And once I've selected that data, I can choose any number of strategies. You're seeing a lot of different strategies here. So if I pick one like PPO, it's going to run a back test, and when it's done running that back test, it's going to say how well it did on that historical data. Now, this might take a while. Okay, great. So it had a 9% loss, not good. But the strategy that worked well for me on this particular testing set was RSI, but there's going to be several other strategies we're going to talk about in this video, and this one made about, okay, 6%. So it's always different, but that's the basic idea here. We can easily switch to live trades as well. That was back testing, but for live trades, all we have to do is click on TradeBot, and that's going to actually make trades using the APIs of whatever service we use. All we have to do is go to Config, add an API key, and then choose the exchange we want to make trades on, whether it's Binance or Bitfinex, whatever it is, add our public and private key, and then it's going to literally make trades for us in real time. Now, this is something that is an ongoing process. This is like a cron job on a server. So you can have it run, once you make your strategy, you set all the details, you can have it, run on your server and just, not worry about it anymore. So that's the goal here. And that's the great thing about having a user interface, right? You can just do this in the browser with clicks and, with typing out. You don't have to always manually change the code. So that's the basic idea behind this. I want to show you how I built it and also show you my strategy of making a deep reinforcement learning agent work inside of this market. The idea I had was, let's take this theory, this space of financial transactions, of financial market prediction, and let's apply some of the most cutting edge AI technology to it to see how well we can do, right? Because we have that domain knowledge of AI theory that even the huge banks like Barclays and Chase, JP Morgan, what have you, they don't have, because they're not in this in the way that we are. So that's what we want to do. And the goal of this video is to show you how I built this, to give you the code. It's in the video description, so that you can make your own personal trading bot for personal use, or you can white label it and then you can sell it to other people as a business. Because this is AI in finance. This is a real world example. So let's look at the stack here. So this is a web app, and I built it with Node.js, which is, if you don't know, it's JavaScript, not just for the front end, but for the back end. Usually we use JavaScript to show our views, to make all sorts of dynamic elements on a page. But with Node.js, we can use JavaScript for message passing and saving data to a database and all sorts of algorithms that happen on the back end, which makes the entire thing JavaScript, which is great. And I got to admit as well, I'm starting to like JavaScript a lot after building all of these startup videos. There's also Gecko. So Gecko was the trading JavaScript repository, the base repository that I used to build off of and add the reinforcement learning code to as a custom strategy. I'll talk about all of this. Convnet.js is the JavaScript library for reinforcement learning that I used. Andre Karpathy made this. And then I'm going to use the sentiment library for sentiment analysis. We're going to, look at different news articles and see, what the sentiment is about a particular stock. In our case, it's Bitcoin. And then we're going to obviously use the Bitcoin API. So this is a cryptocurrency prediction bot. Now you can apply this to other stocks as well, but in this, for this case, I wanted to do cryptocurrency because cryptocurrency is basically made for automation, right? It's, there's lightning fast transactions, high frequency trading with crypto. It's machine payments. I mean, these are payments that machines can make between themselves at a very, very fast rate. And there's no human involved because it's decentralized. So it's very easy to access these APIs, and it's also just fun, right? Crypto's always fun. So that's the stack, right? Node, Express, Mongo for the database, Vue.js, which is a newer one for me, I had to learn in a day. Which is for the front end, which is really cool. It's very similar to React in that it considers different components as these, high-level objects that we deal with. Message passing occurs between these components very easily. So the steps in this tutorial are for me to first talk about what makes a good trading bot, and then we'll talk about the architecture of this code. You and I will install it together on our local machine so you can get it up and running, and then we'll make our own custom trading strategy by using several technical indicators and then implementing it with deep reinforcement learning, specifically Actor Critic, which is a type of bleeding edge technique. I'll talk about that at the end. So what is a trading bot? A trading bot, it's an algorithm that makes trades for you. It's a set of instructions, repeatable instructions that happens every time. And so our job as a human is to encode those instructions and try to think of all the edge cases beforehand, and hopefully it works. And so what's a simple example of a trading algorithm? Let's start with that. So let's look at the naive example first. So what I've got here is some Python code. And don't worry if you don't understand every single detail here, right? I'll explain it to you. So first we import our dependencies, great. Then we import some data set. It's some time series data set. Let's just say, it doesn't matter what it is. It's just a time series data set. Let's say it's stocks. Let's say it's Apple stock. And then we, do some data pre-processing to make sure it's all clean and pretty. And then we're just going to split it into training and testing data, 70-30%, and then we'll plot it. Okay, that's all that code does. And here's the result. This is the result, training and testing, okay? So what we wanna do is starting at this point where the blue and orange meet, that's our starting point. We wanna predict the orange based on the blue. So we wanna make some predictions over time series data. How do we do that? A naive method would be to say, okay, the price of tomorrow is gonna be the price of yesterday, and that's it. And then we just keep doing that. The price of tomorrow is going to be the price of yesterday. So that is called the naive strategy. And this is what the equation looks like. Y hat t plus 1 equals, y at the previous time step. And it turns out if we do that, and here it is, here is that strategy, this is the result. Here's our prediction. So clearly it's bad. So how do we improve on it, right? Well, better than that, let's instead of saying, the next price is going to be the previous day's price, let's say the next price is going to be the average of all the different days' prices that came before it. So it's the average. This is called a simple average. And then we'll code that, and then this is the result. So it's kind of even worse, actually. So we can continue to improve this prediction strategy. Instead of doing that, we can do what's called the moving average. It's an average that we do over, a certain amount of data points, and we continually add all of those up. And so that does a little better, but we can keep going. And in fact, I've got a video that details this. It's called Time Series Prediction. Search it on YouTube, pause this, go watch that, come back, and you'll be a lot more knowledgeable about all the different ways we can predict on time series data. Okay, but the idea is that based on this trend prediction, once we have this trend prediction, then we can tell our bot to either buy or sell. Right? And so that's the crucial part. It's not just predicting the next price in the time series data set, it's also based on that deciding when to go long or when to go short, to use some financial terminology, right? What is our stop loss? What is the lowest, price we want to lose before we're out of the game, right? Let's say if we lose $200, we're not playing anymore, right? So we want to encode that into our algorithm. So as you can see, it's not just time series prediction. There's more to it. In fact, there are 10 steps, and I'll talk about those in a second. So as you see here, it's a two-step process in this graph example. We make a buy if the 50-day moving average is this, and then we make a sell if it goes below some threshold value. And these two simple instructions let us create our first algorithmic trading strategy. But that's very simple. We can continually improve upon it with our knowledge of machine learning and of financial theory as well. And the benefits of an algorithmic trading bot are that it's 100% mechanical, it's always running, there's no human involvement, you can go back, do whatever you need to do while it runs, and it's not emotional like us. It's not always considering all of the different possibilities, it's not getting anxious or depressed or anything. It just follows the rules that we lay out. And this is good. In fact, most trades now, most high frequency trades, thousands of trades a second, are done by machines now on Wall Street. And this shows with this graph right here, since 2006, it continually increases. So you might be asking, well, who is using these trading bots then? Because you don't really hear a lot about it. And in fact, if you Google financial trading bot papers, you're not going to find a lot. Like, you'll find a few, but you're not going to find as many as you would for other applications, like for supply chain monitoring or for mineral detection using image classification technologies, etc. But it turns out that pretty much every bank uses this. They're all using these trading strategies. And if you don't believe that, then let's just go straight to the source, right? Let's look at what some of these banks are hiring for. I just found some random bank. I just Googled a random bank and then trading position. And of course, it shows up here, algorithmic trading developer for Barclays. And so their job is to do development and enhancement on our algorithmic trading and smart order routing platforms. What I don't see is any mention of machine learning, because they probably don't know anything about that. I mean, maybe a little bit, but not as much as us. They don't have the enthusiasm that we do for this technology. So that is our competitive advantage, our knowledge of this technology. And if you feel like you don't have enough knowledge of this technology, just go through my channel and watch all the videos, because it's so dense, all that information. And if you watch a lot of it, you're going to get to know a lot more, a lot faster than you would have otherwise thought possible. So back to those steps about, how do we do this? So let's say we're ready to build our algorithm, right? What do we then do? Once we're ready to build our algorithm, we have to ask ourselves 10 things, right? So it's a checklist. So it's a thought process, and we'd be writing down our answers as we go. So the first is market selection. What market do we want to trade on? Do we want to trade on the stock exchange? So for us, it's going to be the cryptocurrency market. And then the direction of the market. Where is it moving? Well, right now it's starting to go up again. Crypto is starting to go up again. What's the setup? Like, what are the conditions required for us to be present before we enter or exit? Let's say, it's got to be X price when we enter and Y price when we exit. When should you open a position? What is your stop loss? So how do we know when to exit to preserve our capital? Let's say if we lose $200, we're out of the game. How do we know when to re-enter a trade? If we stopped out of a good move, we'd have some, static value for that as well. Under what condition do we take profits? If we've made 400, we're out of the game. Money management, knowing what went wrong if we lost X amount of capital, how big a position are we willing to take? Portfolio selection, what stocks do we want to buy? Well, let's just say Bitcoin in the cryptocurrency market. Do we want to have multiple systems? Well, for now, let's just choose one to keep it simple. And then once we decide all of that, then we can build our strategy, and then we perform back testing with it, which is analyzing its performance on historical price data. And this is everybody that does this in the field, back testing, you got to do it if you're going to make any kind of useful algorithm. And once we've back tested it, it looks good for back testing. We've went through the checklist, then we link to an actual real-time market, and then we can execute it, and then that's it. That's our trading bot, all right? So let me also add to this my own perspective here, in that the general idea in the financial automation space has been to choose some strategy paradigm, of which there are a lot: hedging, execution-based, alpha generating, to name a few. And then based on that, we're gonna create an algorithm specifically for that paradigm. And we're going to use a bunch of technical indicators that we think are going to be most useful. But in the machine learning framework, in the machine learning paradigm, I think instead of choosing technical indicators, we can literally learn everything. We can have an algorithm learn what paradigm to use. We can have an algorithm learn what the technical indicators it should use should be. We can have an algorithm learn what the stop loss should be. We can have an algorithm learn everything. And so it's a way of thinking about things where you have these weight values that are constantly being updated, right? These neural net weight values, and they're being pointed in all sorts of different directions. And to give a kind of on-the-spot example of what I'm talking about, so you can kind of see the way that I'm thinking about this, is DeepMind made this algorithm called a differentiable neural computer, which was incredible. I mean, it was a really cool idea. But the idea was that all of these different components had a weight value attached to it. And so when there is a weight value attached to some component, we can update that weight value using gradient descent. Google gradient descent Siraj to see how that optimization process works. And once we optimize that, everything is learning, right? So all of those weight values are learning. All of those neural weight values are learning in real time. And what this does for us is it makes it so that it's really an end-to-end learning system. And let me just show you one more thing on the spot, like about training. This is a neural net in the browser. And so what I mean by, this learning process is basically this. As you can see, it's moving, data's moving here, and that's the neural net. Definitely check out this playground, by the way. It helps you learn about how they work a lot easier with the visual example. So let's go through the architecture of our code. Let's first of all just download this code and then we'll start running it, all right? So the first step for us is to go to this repository called Gecko that I found on GitHub, and it seems to be maintained pretty well. It was last updated 3 days ago, which is good. And we'll download this code repository. It's got a picture of Gordon Gekko from Wall Street, of course. And we'll open up terminal. And I've already got an instance of it running, but I'll do this again. And I'll say cd into it. Where is it? All right, I'm in. Make this bigger. Now let's see, what does it say? Installation and usage. Let's do this together, okay? So it's like, all right, what do I have to do? Clone it, cd into it, done. Install its dependencies with this npm install only production. Gotcha, npm. The node package manager. Well, I actually prefer yarn, which is similar to npm, so I'm just going to use yarn instead of npm, but it's the same thing. But I like yarn more because it works more often, honestly. All right, so now it's going to just install all the dependencies in the package, and when it's done, let's see what the next step is. We're going to start it with the UI flag, just like that. Okay, great. So it's done. Now we'll start it, and it's saying address is already in use, of course, because I already have the other version running. So now I'll delete that, and now we're up. Boom, Gecko, there we go, here it is. Now, what do we want to do here? Wow, there's a lot of functionality here, right? So, but I already demoed it for you, so you could see, I don't have any data in this version of it, but I can import that data, from a certain range. It's going to start importing it, and then, we can keep moving. But let's go back for a second and let's look at the code. So what are the important parts of this code base? It turns out that for the front end, it's using what's called Vue.js. And like I said, it's this idea of reusable components similar to React that makes it easier to build scalable user interfaces in JavaScript. And for state management, it's using a technology called Redux. And so you can think of all of these circles in this graph as the path that a user takes through the different routes of a web app, from the home page to the sign in, to the account dashboard, to the buy page. And so there's got to be some data that's passed along through these pages. Let's say it's a user ID, there's cookies, there's session ID, etc. Rather than having that data pass through each of these routes, and then maybe the user goes back and then it has to go back. That can be messy. Let's just use an in-memory data store, and then it just pulls from that from wherever it is. And that's the idea behind Redux. for serialization, for configuration, right? We have a lot of config to do, reusable config files for whatever market we want to use, for whatever trading strategy we want to use, right? What are the parameters? What are the variables we want to use? And so Tom is the format that the Gecko library is using for that. It's called Tom's, what's it called? Like Tom's Obvious Minimal Language. It's pretty simple. It's pretty human readable. There's no learning curve really. It's like JSON or any of the other ones. Okay, so that's the basic idea there. There are two basic concepts in this code base. There's the market and then there's the Gecko stream. The market basically pulls data from whatever market we want, and then the Gecko stream will execute, whatever trade we want based on that market, based on a number of plugins, and plugins can do any number of things. So let's go through this. So the GitHub folder is just, GitHub stuff, nothing really related. We've got adapters, so let's make this bigger. So we can use Mongo, we can use Postgre, we can use SQLite. These are all different databases that it could use, but by default, it's using SQLite. And then for plugins, there's quite a lot of plugins that we could use for, any number of different variables, right? And then we've got strategies. Now strategies, in this folder, these are where all the custom trading strategies will go, and we'll create our own as well, okay? And that's it for that. So that's for configuration, all the configuration files. And then in the core directory, that's where we have the core of our repository, right? So BudFox is the real-time market. BudFox is the real-time market. Everything's written in JavaScript. But what it does is it lets the data flow from a market, and all of those parameters around that Bitcoin data, it's going to pull, it's going to format it, and then the Gecko stream will handle that later on. And so candles are, by the way, candles are those, let me go back and show you. You probably know what candles are, but let me just show you. Candles are these little bars, like this red one or this green one, and it shows the difference between the opening price and the current price and the closing price and the current price. And it's basically it's a formatted, pretty way of denoting what the price is at a certain interval and what the change was, what the delta was, and we can input each candle into our algorithm and use that as a data point for trading. So this is what's inside of a candle: the amount, the start, end, first, last, timestamp, a timestamp, etc. And once we created a candle, we have a manager for that candle to say, where does it go, and then this is the heart.js is for the interval. We can set what the interval to pull candles from the web should be. Market Fetcher is the HTTP wrapper around actually pulling that data. And then Trade Batcher batches what we pull into certain sets of intervals. So that's for BudFox. That's a real-time market, but there are other types of markets. We can back test like we just did in that demo. We can import data from wherever. And then there's some tools. There's some workers. This is all low level right here. We don't really need to worry about that. But remember, the Gecko stream is that small writable stream that passes data to all the candle consumers. The Gecko stream is what's going to be handling our trading logic, when we write it. By handle, I mean it's going to decide when it starts, when it ends, when to finalize, when to shut down, gracefully shut down all other variables. There's a bunch of docs. There's the exchange. What exchange do we want to use? That depends. We have a lot of different exchanges here, like Binance has got its own wrapper. Bitrex, all of the exchanges have their own wrappers. Even Coinbase is on here. Wow. So there's a lot here. Importers for the exchanges are a bunch of JavaScript files that say, here is how you format that data that we're importing from the exchanges. The logs file, node modules, we've got quite a lot. Plugins are basically modules that allow our app to basically compartmentalize different parts of our code base into reusable modules. So MongoDB is one. PaperTrader is basically fake testing on fake data. And then there's Performance Analyzer, the Real Trader, and these are all plugins that our stream uses. So these are all going to go into our Gecko stream. Then we have strategies. Now this is where the code is going to go. This is where we're going to create our own strategy, right? This is an example here. And we'll go into this at the end. Testing is for testing purposes, and then web, inside the web folder is the logic for our what do you call it, our web app, and all the different parts of it, like the index page, the landing page, etc. We can change the user interface there. And that's it. And then the rest are just configuration files. But that's it for our code. Now, that was our first step. We installed it, and now we're going to install the rest of the machine learning to actually make our own strategy. But before I do that, let me also say this. There are actually quite a lot of technical indicators that we can use as signals to our trading algorithm. And there's a lot of theory behind this. I mean, these are terms that are not used in machine learning: force index, volume price trend, average true range, Keltner channel. I've never heard of any of these before. Vortex index, mass index, money flow index. There are quite a lot. And so the idea is that we just pick and choose some, and then we test it out with back testing to see how well it did with our algorithm. And depending on how well it did, we then decide whether or not to use that model. So there's quite a lot there. So what we're going to do is we're going to pick one, to start off, and then we're going to keep iterating from there. All right. So now for our last step, building this trading strategy. Okay. So we're going to build what's called an actor critic deep reinforcement learning algorithm that will make trades as per necessary. Now I'm going to explain to you how this works. All right. This is cutting edge reinforcement learning. By the way, if you're actually interested in reinforcement learning, search Move 37 on YouTube by me, and there's an entire playlist that I dedicated to teaching you reinforcement learning from start to finish, and it'll show you everything. It didn't get that many views compared to my other videos on supervised learning because reinforcement learning, it's not as obvious how reinforcement learning can be used for business use cases. That's why. There's always that profit motive that helps drive viewership, I've learned in my videos. So my job is to find the intersection between what is high impact and what is also profitable for my users, or my audience, my wizards, my students. And that is the kind of content that I want to make. Reinforcement learning in the context, I bet this video is going to get a lot of views, by the way. Reinforcement learning in the context of something like this that drives a lot of attention is a way for me to sneak in a lesson on cutting edge AI and help educate the population on how this technology works. So ready? Now that I've got your attention, here is how deep reinforcement learning works. Here we go. So in reinforcement learning, this is going to take 5 minutes, don't worry. In reinforcement learning, what we first do is we frame our problem as what's called a Markov decision process. This is a frame. It's a frame of thoughts to help us reason about what the algorithm we want to use should be like. So the Markov decision process involves states, actions, and rewards in an environment, in any kind of simulated environment where time is the label, where time is this continuous process. That is when we would use reinforcement learning, like in a game or like in a market, a financial market. The idea is that an agent will take an action, and in our case, that would be buy, sell, or hold. Now, depending on that action, the agent will receive a reward. In our case, that reward will be +1, -1, or 0, based on whether or not we made a profit from doing that action. And then once we get the reward, state, action, reward, right? Once we do that reward, we move on to the next state and we record what the result of that reward was. And this will form what's called a policy. And that policy basically says what action to perform given whatever state we're in. Now, the state in our case is going to be the state of the market. Now, the market actually has several agents. We're not the only agent in this market. There are other traders making trades, and these are all influencing the price in different ways. Now, a really, really good trading strategy would take into account other traders as well, and we would consider that a fully observable Markov decision process. That is like V2. V1 is a partially observable Markov decision process, where we consider ourselves the only agent and all of the technical indicators are our input data, not necessarily other agents and their actions, because then it becomes a fully observable Markov decision process and it becomes multi-agent reinforcement learning. So that's the idea. We have a state, we perform an action, we go to the next state, and we get a reward whether or not, we're completing our objective as per necessary. That's reinforcement learning. Now, where the deep part comes in is we use a neural network to estimate the policy. That is the part of reinforcement learning. We use a neural network to approximate the function that is our policy over time. So the Deep Q network that DeepMind used for Atari games was one example of that. AlphaGo, what else? AlphaGo was an example. OpenAI's 5 is an example. All those latest breakthroughs, they're all using deep reinforcement learning. And this is what my friend Lex Friedman talks about as well all day, deep reinforcement learning. My podcast is coming out, by the way. I can't wait for that. That's going to be sick on his channel. Check that out later. So that is the Markov decision process. Now, that is how we frame our problem. Now, based on that, we know that we need to use a partially observable Markov decision process. We have a single agent, and the state is observed indirectly. We have tunnel vision. We can't see any other traders around us. And when we do that, we choose an action, execute it, observe the result, update our belief, and then using that belief as input, redo the process over and over and over again. So that's reinforcement learning. We can then split reinforcement learning into two types, model-based and model-free. Now, model-based, it's good for, we have a set model of the world and, we're going to predict a lot. But I think the more interesting techniques are model-free. There's no model of the world. It builds that for itself. And we can further subdivide these model-free methods into two types, value-based and policy-based. And so the method we're going to use is a policy-based method. So the policy decides, it's a function. It's just a function. It's an equation that decides which action to take given the state. But how does it decide what the value of each state is given an action, right? How do we rate all of those moves on the chessboard? How do we rate all of the potential states of the world given actions? Well, that's where the value function comes into play. The policy uses the value function to decide what move to take. So there are actually two functions involved here, both a policy function, which is high level, and then a value function, which is low level. Assess all of the values of all the pieces, and that's the value function. So a value, and then the policy decides, okay, based on that assessment, which is the best one, or which is the highest value. Okay, this one, that's the one we're going to take. You see what I'm saying? So there are two ways of separating out reinforcement learning paradigms in the model-free paradigm. So that's the idea. But it turns out that both value-based methods and policy-based methods, there's some methods that only focus on the value function. There's some methods that only focus on the policy function. The better version of this is to combine both, and that's actor critic. It's a hybrid approach to both. So how does this work? Well, we have two neural networks. We have a critic network, and then we have an actor network. What the actor network does is it controls how our agent behaves. It makes buys, sells, it makes holds, whatever, all those actions. The critic network is watching the result of the actor network, and then it's going to measure how good it is, and it's going to output a value, yes, no, good, bad, or neutral. And then based on the output of both, buy, sell, hold, good, bad, neutral, we'll take those output values, and then we're going to perform optimization based on those outputs, and that's the learning process. That's how all neural networks learn. We have an initial output, and then we compute some gradient-based optimization process. Again, gradient descent Siraj if you want to see how that optimization process works. So that's the basic idea there. Mastering this architecture is essential to understanding state-of-the-art algorithms like proximal policy optimization, which OpenAI released very recently, and others. But the idea is that the actor says, I'm going to rotate this piece, and then the critic's like, that's really bad, or that's really good. That's the critic part. And then mathematically speaking, we can say, here are the equations that represent both the actor and the critic. The first is the actor, the second is the critic. And these are two weight values. So state, action, and theta. Theta is the weight value for that network. State, action, W. W is the weight value for that network, which is a matrix, a set of ones and zeros, numbers that change over time as it learns. And that's the basic idea. And what happens is over time, we can either have this happen synchronously or asynchronously. The asynchronous way is really interesting because we're going to have several actor-critic models over time, and they're all going to be learning at each time step. And over time, based on the actions that it takes, it's going to optimize itself and update its weight values. So in the context of our problem, how does this all play out? The environment is some time series data. That is our, Bitcoin price data. The observation that it's going to make is going to include the price data, any other technical indicators that we want to input, all those features, okay, to use machine learning terminology. That's the observation. The state is going to be the account balance, right? Whatever we are at any time. And then the action is going to be either buy, sell, or hold. The reward is going to be some scalar value, +1, -1, or 0, based on whether or not we made a profit. So the simple example of this Markov decision process, we can code out in Python using OpenAI's GEM library. We have an environment, we make an observation, and then in this loop process, this is the Markov decision process, we make an observation, and then we use that observation to make an action, and we repeat that process over and over again. Now, in the context of a market, in the context of a financial market, I found this other repository called Siren. Look it up on GitHub, Siren, which basically modifies that OpenAI GEM environment so that one of the environments is a real-time data feed from a market. And then, so let's say it's Apple stock. Then we'll create an agent called an actor critic, and then we'll do the same thing with that. And the result is going to be, several actions. Like that, all right? So that's the basic idea. But I found it easier actually to build off of that Gecko repository because that UI is so amazing, and then add in machine learning via Tensorflow.js or convnet.js or what have you. So let's get started with building our custom trading strategy. So what we're first gonna do is we're going to look through the sample config.js file. Okay, so this is the sample.config.js file, and it's got a bunch of variables that are it's just sample variables. But what we're gonna do is we're gonna take all of it, we're gonna copy it. So we're gonna go all of it. And once we have copied all of it, we're going to create a new config file and we'll paste it in and we'll call it config.js, okay? So now that we have our config file, we'll set the exchange to the one that we want, which is Poloniex. And once we have that, we're going to create our own strategy. So under strategies, we will create a new strategy. So we'll say new file. We'll call our strategy, we'll call it deeprl. Let's call it deeprl. So we'll start off by saying, okay, so this is called deeprl.js, deeprl.js, okay? Now, we'll start off by saying, here's my strategy. Well, this is gonna create our own strategy. And then we'll also just do a console.log for hello world just to make sure that we're doing everything properly here. And once we have that, we'll go ahead and prepare our strategy with the init function. Strat is short for strategy. And so that's for preparing everything our strategy needs function. And then we're going to do one more. What happens when we update a candle? So there's going to be an event listener that's waiting to see what the next thing to do is. And lastly, for debugging purposes, we have this built-in log function. Now remember, this is an interface, so it's all of the strategies are expected to implement some version of this interface. Once we have that, we'll actually, there's two more actually. There's the check function. So based on the newly calculated information, we want to check whether or not we should update or not. So we'll say this advice.long. So long is actually going to wait. It's going to say, okay, I don't want to sell right now. And then I'll have one more, which is the ending function, which is optimal for executing code after the completion of a back test or some strategy. And lastly, I'll export the strategy, and that's it. And then once we have that in the config file, we can run this config.js function. And what that does is it says, we're gonna run a back test without the UI directly from terminal using that config.js file. And it's gonna see what's in there. And I had that hello world, as you can see here. And what it did is it looked through all the back testable data that we had, and then it performed our algorithm. So now in Moon, I'm gonna rename it to Moon. I'm gonna add the code in here. So we will go to this repository right here called Neural Network Strategy for Gecko, and we'll look inside of it, and it says, okay, this is the strategy, let's add it to this. And so this person already created this strategy using convnet.js. Let's look at what the strategy does. So this is a strategy, just like what we have, see var strat. And inside of this, they've implemented the interface necessary, the init function, et cetera, the update function, just like we have here, init update. So they already have that. Okay, so if we go here, we can see what it's doing here. So SMMA is the only indicator that it's using. So if we go to SMMA indicator, that is the smoothed moving average. So that is the one indicator that we're using here. And here's the formula for that. It's taking the closing price It's taking the sum, it's taking the average, and it's using that to compute an indicator. Now, these are statistical features, right? So just like in the rest of the data science pipeline, we compute a set of statistical features and use those as additional features as our input to our model. Okay, so in the strategy, we're saying here are the hyperparameters for our neural network. Initialize the strategy, name it. Here are our layers that we define the input using those parameters. We initialize a network. We use stochastic gradient descent to train it. That's our optimization strategy. And then we say, okay, increase the prediction count by the number of times we predict our data, but we're training it on the past prices. This is our training function. Now in our update function, once we've trained our model, we can say, okay, on function event, on trade, if our stop loss is this amount and we set that stop loss as a threshold, then we're going to either buy or sell. And those functions are listed inside of this right here. It's like if buy, do this, else go long, this dot advice says that. And so you can see this set of if-then statements that define this strategy of using this neural network. Now, if we consider the paradigm of this code, like the way that it is, you'll notice that it is basically reinforcement learning. This is the Markov decision process. It's just not called that explicitly, but that's what it is. So when we add a neural net to this, we get deep reinforcement learning. Now, this is going to act as an initial strategy. This is not actor critic. This is just one neural network, right? So we want to add in the actor critic functionality, but this is our initial neural net that is our trading strategy. Now, when we connect it to Binance or whatever our website is that we want to use for real trades with our config key, then we can actually make real trades with this. Now, is this going to work every single time, by the way? No. Is this like, am I, the next financial advisor? No. I'm a, machine learning engineer, data scientist, and this is just an interesting problem. And I want to push these ideas of deep reinforcement learning out into human consciousness. So hopefully we solve AI, because that's my real objective. So that is that. Now, what else can we do here? Well, we can make sure that actor critic works. So what else can we do? So luckily that was like a pre-built strategy, but let's see what else we've got. If I search actor critic JavaScript, we can use reinforce.js. Perfect, a JavaScript library for actor critic for deep Q learning. And we'll create our agent and then we'll run it in the environment, and that's how that goes. Just like that. Just like that. So we can add this as well to our function in the init file if we wanted to, but I think this neural net for now with this one single indicator. Now, of course, we can add more indicators as well to increase the accuracy of our model. And so back in the UI, if we wanted to, we can run a back test as well, and then we can get the results as this very pretty line graph. All right, so that's my demo for this video. We can improve this in a lot of different ways by using more technical indicators, by using different types of models, by increasing the types of tests that we do. There's a lot that we can do. So yeah, I hope you found this video useful. Do you have an idea to use AI in finance? Let me know in the comment section, and please subscribe for more programming videos. For now, I've got to work on a different project, so thanks for watching.